Hello guys, happy Friday. Just going through some of the homework assignments, recent homework assignments. Um, Also, you might notice I posted some bonus today in Google Classroom. Be sure and get in there and get a chance to get some extra points. And also today is a day to kind of make up some of the work. Some of us have gotten really far behind. We need to get that stuff done. But for right now, we're going to focus on function domain word problems. And it says the altitude at which we boil an egg affects how long it takes for the egg to achieve perfect hardness. It takes 198 seconds to boil a perfect egg at the lowest place possible, the edge of the Dead Sea, which has an altitude of negative 418 meters. The highest place possible is the summit of Mount Everest, which has an altitude of 8,848 meters. It takes 209 seconds to boil a perfect egg there. TA models the time in seconds it takes to boil a perfect egg at an altitude of 80 meters. What number type is most appropriate for the domain of T? The domain is the x's that we're putting in. What we're getting out here is seconds. What we're putting in here is altitude. Think about how you're going to measure your altitude. You're almost certainly going to measure your altitude in nice meters. Like they're not going to measure an altitude in square roots. So the difference between integers and real numbers is integers don't have weird decimals. They don't have square roots. They're basically, -3 is an integer, 7 is an integer. There's no decimals, no weird fractions. So that's what's going to be happening in this problem. Our domain, the numbers we're putting in for our heights, for our altitude, is going to be a nice integer. It's not going to be something weird or ugly. And then we want to know what the appropriate boundaries are. Well, if you go up here, it says the altitude of the Dead Sea is negative 418 meters, and the altitude of Mount Everest is 8,848 meters, and everything has to be in between. Now, again, TA models the time it takes to boil an egg at 80 meters. So our altitude is our domain, our seconds is our range. So when we want to know our domain, it's going to be between, but it's also going to include those two heights. So it's going to be between negative 418 and 8,848, but it also has an equal to because you can theoretically be at those specific heights. Now, this is where they're disagreeing with me, and I'm going to, it's fine, I missed it. Here's why. I'm guessing they're going to say you can have a decimal number of meters. That's kind of a weird thing to do, but I'm going to guess that's what they did there. There we go. Happens to all of us. I miss things too. All right. The house numbers on a certain street go from 1 to 88. The function B models the type of building whose number is in according to the following key. Residential building, function output is 0. Commercial building, function output is 1. Governmental building, function output is 2. Other, function output is 3. Which of the number types is more appropriate for the domain of B? Okay, so the domain of B is a house number. Now, the last one, we could have gotten an argument about whether you would put in nice numbers or maybe you could put in decimals or whatever. Here, house numbers are definitely not decimals. House numbers are absolutely integers. So the building type, the house numbers of a certain street go from 1 to 88. The function BN models the type of building where the number is in E according to the following key. Okay, so you're not going to have a house number which is going to be a decimal. That's not going to happen. And again, it tells us that basically we're between, again, domain is numbers we put in, range is numbers we get out. Our domain is going to be between 1 and 88, and it's going to include them. All right. Tanya walked for 17 minutes from her home to a friend that lives 1.5 kilometers away. DT models Tanya's remaining distance to walk in kilometers, T minutes since she left her home. What is the type of appropriate for the domain? Okay, so again, our domain is about the minutes, it's about time. Now, Could we have a decimal or a fractional version of time? This gets us back to number one. Why we missed number one is we thought, well, they would put it in even meters. But here, definitely, since the first one they considered that to be a possible, then absolutely we could have some decimal version of time, like 1.2 minutes. So we absolutely can do that. All right. So that's where that would come from. And so we have to have real numbers. Now, I still don't think you'd end up with a weird square root, but you definitely could end up with something like 1.3 or some type of not relatively nice decimal, not some infinite decimal, but some relatively nice decimal. So we would say the real numbers. Although we could get into an argument about whether we should consider them the rationals or whatever, but we'll definitely go with real numbers here. Now, again, our domain is about minutes. So it's going to be about the minutes. And again, we started it, she hadn't left yet, and it's going to take her 17 minutes. So it's going to be between 0 and 17. All right, last one. Mason stands on the 5th step of a vertical ladder. The ladder has 15 steps, and the height difference between consecutive steps is 0.5 meters. HN models the height above the ground of Mason's feet in meters. After moving n steps and Mason went down the ladder, n is negative. What type of numbers represent the domain? Now again, this functional is modeling height is the output, steps is the input. So steps is our domain. Well, you're not, again, taking a fractional or decimal step. So the steps are definitely integers. And then there's somewhere, okay, there's only 15 steps. Now, this was a little bit of interesting is, are we talking about being from 0 to 15? Now, they make this easy because there's not one that they're talking about. Let me organize my thoughts. Okay. Mason's feet in meters after moving n steps. If Mason went down the ladder, n is negative. Okay, so he's at the 5th step. He's going down the steps. Now, he can only go down 5 steps. That's where n is negative if you go down. If he went up, he would get to 10 because it says n can be negative. This doesn't have n being negative. It's got to be between -5. If he went 5 steps down, he'd be at -5. If he went 10 steps up, he'd be at +10. All right. It's fairly straightforward, not too bad. I always tell people if something I said didn't make sense or I wasn't 100% clear, I do these colds. Sometimes I don't think about them 100% correctly. Ask a question.